I've always been interested in the small things in life, in particular sort of bacterial cells, the smallest independent life form that we know of, but they're incredibly complicated. And of course they've been on the earth for 4 billion years, so they're extremely successful. Despite all of that, we know very little what are the machinery and the mechanisms inside the cell which will allow them to be so adaptable. My name is John George, I'm a reader, and my research area is microbial biochemistry. Estimates today suggest that by the year 2050, bacteria will cause more deaths than cancer. There's not been a new class of antimicrobial discovered since 1967, which tells you really how clever bacteria are and how difficult it is to find new antimicrobials. A new antibiotic can be used clinically for as little as 1 year before it has to be abandoned because of widespread resistance. If you understand biochemistry, to some degree you understand what makes life tick. Understanding how DNA interacts with RNA, which interacts with proteins and interacts with metabolites. Life is a dance between all of these layers of life. The outcome of it for me originally is to understand how cells regulate their biochemistry. We found out quite quickly though that you can use that same technology to find out how to kill bacterial cells, how to discover possible antimicrobial targets. One day the goal is to have a model which can predict what that organism will look like and how it will grow, how it will divide, and importantly, what are the weak points in that biology? And that is where we can perhaps go in and design new antibiotics against.
Academics at our university listen, inspire, challenge and innovate. They transform the way our students think and view the world. See how our academics and their research is making a real difference.